Okay, now so we have done this with respect to spherical coordinates. Now with respect to cylindrical coordinates, so we are again going to rewrite the region. So we have x square plus y square plus z square equal to 2az. So adjusting this, we'll read to x square plus y square plus z square minus 2az plus a square equal to a square, or simply x square plus y square plus z minus a square is equal to a square. Okay, so we have this sphere and we have a cone. So as we have seen in the previous video, we draw our sphere of center 0, 0, a, something like this, and we have a cone at this point. Okay, so this is my center, this is my sphere. So where will they intersect? What is the intersection point? So at intersection, we know that we have to equate these equations. So at intersection, I know x square plus y square is z square. So I'll just put it over here. So we will get z square plus z square equal to 2az, or simply z square. So if I add them, so 2z square is equal to 2az. So that means 2 gets cancelled. That means z minus a is 0. So the intersection is either at z is equal to 0 or z is equal to a. That means this point is, this is the plane. If we take where they intersect, the plane is z is equal to a. Alright. Next is we have to imagine a cylinder, because we have to take a cylindrical coordinate. So we will take a tight cylinder bounding the region, and we have to find the volume of the shaded region. Okay, so for cylindrical coordinate, we know the cylindrical coordinate system. We know that x is r cos theta, y is r sin theta, and z is equal to z, where theta is from, so if we analyze the xy plane, it will be a circle with radius a, right? So if we take here z is equal to a, that means x square plus y square is equal to a. So the same thing will happen on the xy plane. Hence we can take where theta r is from 0 to a, theta is from 0 to 2 pi, and for z, what we are going to do, we are going to take a strip parallel to z axis. Okay, so something like this. So we can see the lower end of the strip is on the cone and the upper end is on the sphere. So that means z limit is from x square root of x square plus y square less than or equal to z less than or equal to square root of. So from here, if we see, so z minus a square is a square minus x square minus y square, or simply z is a plus square root of a square minus x square minus y square. Alright, so this is going to be our value of z on this sphere. That means this is given by z is equal to a plus square root of a square minus x square minus y square. So since z is everywhere positive, we are taking the positive square root. So the upper limit will be a plus square root of a square minus x square minus y square. Alright, but our x is r cos theta and y is r sin theta. So if we substitute here, we get r less than z less than a plus square root of a square minus r square. Alright, so this will be the limit for z. We got the limit for r, theta and z. And obviously the Jacobian of the transformation is r. So the volume is triple integration dx, dy, dz over the region S. And since we are doing the change of variable, so we need to multiply by the Jacobian. So that will be triple integral r, and then we can take anything in any order, it doesn't matter, only r should come before z. Okay, so we will take d theta, dz, dr, where theta is from 0 to 2 pi, z is from r to a plus square root a square minus r square, and r is from 0 to a. Alright, so we will integrate, so we get this, so we will integrate them one by one now. So we can see here, this is integral 0 to a, r to a plus square root a square minus r square, r, and then integral 0 to 2 pi d theta, dz, dr. Okay, so This integral is going to be 2 pi because this will be equal to theta from 0 to 2 pi, and upper limit minus lower limit is going to be 2 pi, so I'll take that out. So 2 pi integral 0 to a, then r is a constant with respect to z, so r a plus square root a square minus r square, and then finally we get dz dr. Alright, so this comes out to be 2 pi 0 to a r, this is z a plus square root a square minus r square dr. Okay, sorry, 0 to a, and that is now equal to, so this is equal to 2 pi and integral 0 to a r, upper limit that is a square minus r square minus lower limit dr. Alright, so we will split each integral, so that is equal to 2 pi, and inside we have integral 0 to a ra dr minus integral 0 to a square root of a square minus r square dr minus integral 0 to a r square dr. Alright, so evaluating one by one, so this is 2 pi, this will be a is a constant, so that comes out, and this is r square by 2, 0 to a plus 0 to a, I am keeping it as it is, a square minus r square into r dr, and the last one will be minus r cube by 3, 0 to a. Alright, so I will evaluate this separately. So we know what is integral 0 to a square root a square minus r square dr. So for that we will put a square minus r square is equal to x. That implies minus 2r dr is equal to dx, and limit will also change. So we can see when we are putting r goes to 0, that would imply x goes to a square from here, and when r goes to a, that would imply x will go to, if I put r is equal to a, this will become 0. So therefore we get integral a square to 0 square root of x minus dx by 2. Alright, so minus half I'll take out, and this integral is x raised to 3 by 2, so square is here, so 3 by 2, and a square to 0. Alright, so this becomes minus 1 by 2 into 2 by 3, and this is upper limit minus lower limit, and by law of indices we can see that minus minus becomes plus, and indices law will make this a cube. So final answer is a cube by 3. Okay, so this minus gets cancelled, 1 by 3 is present, and this is a cube. So therefore this integral we know is equal to a cube by 3. Okay, here obviously r is there, sorry, so the outside Jacobian. So now we are going to put it over there. So we get this is equal to 2 pi, this is a, and upper limit that is a square by 2, plus this part we evaluated is a cube by 3, minus this part also we evaluated, that is a cube by 3. Okay, so they will cancel, and we will get 2 pi into a cube by 2. So 2 gets cancelled, and the final answer is pi a cube. The same thing which we got in the case of spherical coordinate system. Okay, so that is going to be the final answer. Thank you.